These ones are faulty.
You can have it. 100% of 0 is 0. Do people not ever try to return food to bushes? Trevor, people try to return things to bushes? Like food? Does that ever happen? Really? What do? They just give a new one. You ready yet? Okay. So, again, this might be, you might not have enough room on this sheet, but you might want a separate sheet if you write big, and so it's up to you. But I want to go through a couple of these examples. These are from AP tests. These are a little tougher than the ones that I did with you in class on Tuesday. And then I assigned you con also, that is due Friday. But to be completely honest, it's not like I'm going to check it over the weekend. So if you had it done by Monday morning, you'd be okay. Yeah. So, alright, so let's go through. There's just a couple little like twists that these can do that you can do in here, and I want to go through a couple of those. So, read through number 1, and we'll start doing it in a second. Does everybody have it, right? Everybody came in later, got it? We're good? Okay. So I'm going to start labeling on the drawing what I know, and kind of hopefully figure out from there. So I know Y is 3, I know X is 4, and then because of those two things, I know Z is 5, right? Because of Pythagorean theorem. Well, the sides of the angle are increasing, so it's like this rectangle is expanding. So we're also going to have dy dt, dx dt, and dz dt. We got to figure out what those are. But they don't give us numbers for them. They give us kind of a weird setup. So they tell me dx dt is equal to dz dt. And they tell me dy dt is equal to k times dz dt. So they're kind of putting everything in terms of dz dt. So like where I have this dz dt equals, I don't really need it. Because they just related everything back to dz dt. You can see how I labeled these and why. We alright? So my first job is to find, I guess that's my first job. My second job would be to find an equation that relates, the sides of a right triangle. So what's that? Pythagorean theorem. So I'm going to go x squared plus y squared equals z squared. And we're trying to find k, which is a little different than we're used to. So what do I do now? Take the derivative. Is that a paper tip? Tilt it so I can see it. 3 in 1.
That's not flying very well.
I was just going to ask that. Okay. Alright, back to the problem. Take the derivative. So 2x times dx dt plus 2y times 2y dt equals 2z times dz dt. And I'm going to plug in what I know. In this situation, basically we're going to, what's the two variables we're going to have in here at the end, because I know x, I know y, I know z. This, I'm going to substitute the thing with dz dt in it. This, I'm going to substitute the thing with dz dt in it. This, I'm going to leave as dz dt. So I'll have dz dt in there, and I'll have a k in there, which is z. My job is to solve that. So the first time you see these, they're a little weird, but I don't think it's too bad. So what's x? What What's dx dt? dz dt. What's y? 3. What's dy dt? K times. Imagine like walking into this class having no idea. Like, think about what we just said. Or maybe if you're in this class, I don't know. What's z? 5. And then dz dt, I'm just going to leave. Questions on what I'm putting in where and or why? Can you solve that for K?
Try.
Well, I'm asking you to try. Give me your best shot. I'll do it in a second. So what you got? You alright? Jeff, can you mind your way? What do you... Can I help you? You say you're straight. Just look. I didn't mean to pry. You can do whatever you want.
You say you're so scared of failure, so you're not going to try.
That's way more common than... No, but if you can justify it by saying I didn't really try, so if I would have tried, I could have done it, but I just didn't try.
I'm
So.
pretty sure I'm stupid, so I'm just
It's not a good attitude, but it's very common. I mean, you have the edges in front of you.
Oh, yeah.
Right?
That's how I know I got it right.
Okay,
That's how I clicked it.
so 8 times dz dt plus 6k times dz dt equals 10 times dz dt. But what's in every single term is a dz dt. So can you cancel those? And then you get 8 plus 6k equals 10. So 6k equals 2. So k equals 1/3. So it's b. How many had b? Okay, questions? We're good.
You can also just immediately take it to an What?
Yes, you can. So you could have done that like here, you're saying, right?
Yeah.
So it's just a little, yeah, no, that's good. That's cool. Other questions? Alright, I don't think 2 is too bad, but realize on 2, so my hint would be when you take the derivative of that, what do you have to use? You have to use product rules, so keep that in mind. So you might just want to make a little note there. Let's look at 3. And I'm going to give you a second to try it, and then I'll go through it. Like some of these I can't tell if you'll need help with or not. We'll have to kind of see. So try it. You might need help. You might be like, this is easy. You might be like, I have no idea. I don't know. Give it a shot. We'll go from there. Remember, you have the answers, so you can check. You're not wanting to wait until I get to it. circle and I've got area, so I'm gonna start there. Area equals pi r squared. And then I see that it's increasing, and we got a radius increasing, so that means we're related to time, right? So I'm gonna take the derivative. So the derivative of a is dA over dt. Pi r squared becomes 2 pi r times dr dt. Now they don't really give me numbers, but they tell me the area is expanding or is increasing twice as fast as the radius. So that means dA dt is 2 times dr dt. The area is increasing twice as fast as the radius. That makes sense where I'm getting that from. Yeah.
How did you get that?
How did I get this?
Yeah.
I was talking about it while you're on your phone, if you really want to know. Yeah. So I'm gonna give me to go through it again.
Yeah.
Even though you're on your phone, I gotta do my job twice. Right, but you were when I said it.
I'll go through it again.
No, I'm gonna go through it again. So the area is increasing twice as fast as the radius. So dA dt is the change in the area, dr dt is the change in the radius, and this is twice as fast. Well, then if I go over here, I can put 2 times dr dt in that spot equals 2 pi r times dr dt. And they're asking me for the radius. So what can I cancel out here? 2. Cancel out the dr dt, but be careful because you still have something left over here, even though cancel. What's really over there is a 1, right? So you got 1 equals pi r, or r equals 1 over pi. Questions there? How many had that? Alright, let's go. Did you figure out what you did now?
I did it all right. I just got the last step.
Oh, really?
Yeah.
Let's do 4. Or, try 4.
Thank you.
This K thing, and they take like a concept that you learn and then they make it twist it. Okay, so let's go through it. So the rate at which the third root of x is increasing. So you're starting off with your equation y equals x to the 1/3. So they don't give you the y part, but that's really what we're doing. That might mess people up too. Like, what do I set this equal to? And then I'm going to take the derivative of both sides. So dy over dt equals 1/3 x to the negative 2/3 times dx dt. So this is, the y is like the area kind of, and they're saying that that is increased. So the third root of x is increasing. The third root of x is the same as y, isn't it? Like that's what the y would equal. So y is increasing 1 over k times the rate at which x is increasing. So dy over dt is 1 over k times the rate at x is increasing. So dx dt. So the y part is huge. Like if you didn't put a y there, you're kind of stuck from the get-go. And then they're saying that y value is increasing at 1 over k times the rate at which x is increasing. So then I can do my substitution. Okay, 1 over k times dx dt equals 1/3. And what's x? 8 times dx dt. Questions on what I'm doing there? So now what happens? What can I do on both sides now? I cancel the dx/dt's, right? And then it's 1 over k equals, so now I gotta do, I know you guys love these. What's the third root of 8? 2. 2 squared plus 4, and what does the negative sign do? Flips it over. What?
Do that, right? You raise both sides to the.
Yeah, I'm getting it. So you're okay, you're like a step ahead.
Oh.
Gotcha, okay. So third root of 8 is 2, 2 squared is 4, and then the negative flips it over, is 1/4, right? So what's 1/3 times 1/4? So I don't even know if we need, so what Josh is saying is we can raise both sides to the negative first, but if 1 over k equals 1 over 12, what does k have to equal? Has to equal 12, right? So, used it right away.
Yeah.
Oh, gotcha. Okay. How many got 12 then? Found something. Question on it. Like, does that help? If you didn't get it, does that help?
Yes.
Okay. You know, you I don't think 5's too bad. I don't think 6 is too bad. Not that they're simple. I'm just trying to figure out like little goofy ones. Let's do 13. No, let's do 14. It's the same problem, but it's got pictures. So it's a little easier. Throw a ladder with my god, right? That's the protagonist there. We had it. So 15-foot long ladder. We got a Pythagorean theorem here, right? Because we're gonna have like a right triangle. So z is 15. That's the length of the ladder. And I'm gonna call the up and down y. And I'm gonna have dy dt. And then the bottom I'm gonna call x. And I'll have dx dt. What's dz dt in this situation? It's 0. That's like how fast the ladder length is changing. It's just not, right? So the ladder is sliding down the wall at a constant rate of 2 feet per second. So dy dt is -2. Oh, it's not a Pythagorean theorem, it's radians. Oh, okay. So we got a different volume. So it's this guy here is your angle. I need a bigger picture. Were there angle ones on Con too? So x is 9. Where am I getting that from? So, it says it's 9 feet from the base of the wall, right? Dx dt, I don't think I care about actually, but we'll see. Z is 15. What's y then? If this is 9, this is 15. What does y have to be? 12. 3, 4, 5 triangle, right? Well, if I multiplied all those by 3, it would be a 9, 12, 15 triangle. I've got the 9 and the 15, so y is 12. dy over dt is negative 2. dz over dt is 0. I don't even know what I need yet. I'm just kind of writing stuff. Theta radians per second. Okay, so I'm going to use, I don't know dx dt, so I don't want my x involved. So I want to use the y and the z, and if I'm at this angle and I want to use the y and the z, what trig function is that? Sine, right? Because I know the opposite and the hypotenuse, so I'm just kind of skipping that part. So right now, sine of theta equals 12 over 15, and I'm looking for like d sine theta over dt. I'll be honest, I'm not entirely sure I'm doing this right, but we're going to see. Alright, so sine of theta equals y over z. Agree with that? Very good. I'm going to take the derivative of everything. So d sine of theta over dt. Oh, no, this doesn't feel right. Well, I'm just going to keep going. We'll see. I'm going to do quotient rule over here. So it'd be z times dy dt minus y times dz dt on top over the bottom squared, so over z squared. But I'm going to find change in sign, not necessarily the change in the name. Z is 15, dy dt is negative 2, y is 12, dz dt is 0. Does it? Don't encourage me? Is that what you said? Wait, no it doesn't. What'd you get?
I got negative 30 over 25, which is
Yeah, but the answer on the SAT says
No,
the
answer on the
answer.
So I think you're wrong.
Oh, I was wrong. Wait.
30 over 225 is not the same thing as 290. No.
How?
You can get rid of
Wait, how did
one of the.
you divide by 15?
She was right by
Oh,
15.
the over 15. Yeah.
Which gets you? You can just cancel out the 15. You get negative 2.
I think this
Oh,
process
wow.
just I'm pretty sure this was wrong.
Yeah, so that's negative 2/15, but that's not the answer.
So if you just throw a cosine on the left.
If this way is 6 that way.
Oh! Wait, oh.
I was wondering if it was going to be cosine. Oh, I wasn't going to point it out because I thought you kept that there for.
Wow.
Oh, I bet
I was trying to make it clear that I didn't know what the hell I was doing.
Oh,
But
okay.
no, I got it. Okay. All right, I got it. So, how about we start over? Is that all right?
Yeah.
Okay.
Is there a certain point where we did it right, or should I?
We were,
We had multiple.
yeah,
Then we would. That's just.
some good, some bad. The part where I took the derivative of sine and didn't write cosine wasn't that good.
Okay, I guess.
Okay. So, sine of theta equals y over z. We all good there? So, I don't know why I did this. What's the derivative of sine of theta? Cosine of theta times what? D theta over dt. So you took the derivative of a theta, so you multiply by d theta over dt. Just like if you took the derivative of y, you multiply by dy over dt. That's why I went wrong. I would say b, but it's not your fault. It's mine. And then the quotient rule part of the right hand side was correct. So the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. But now I can plug in over here also. So what's cosine of theta? Yeah.
Is it z constant?
Yes.
So why do we do the quotient? It's effectively what it means.
I don't. I'm doing like a process that will always work. And that's like, I'd like to give a general, So the z is constant, so we don't really need quotient rules. So I could go over here and go, well, that's just sine of theta equals 1 over z times y. But I feel like that's more confusing in the general aspect than going through quotient rule. So you're welcome to do it that way if you understand what I was just saying, but I think it's more likely most people don't. But that's fine. Is that fair enough, Josh? So what's cosine of theta? 9/15 times d theta over dt. And then z is 15. dy dt is -2. Y is 12. dz dt is 0. This is where Josh is saying like the quotient rule doesn't really matter because this part's 0 anyways. Over z squared, so over 15 squared. So when you work out the stuff on the right, like we did before, we got -30 over 225, which reduces to -2 over 15. Or like a couple people pointed out, cancel a 15 here, cancel a 15 here, those go away, and what are you left with? It's just the -2 over 15, right? So they're asking me at what rate is the angle changing? So I want d theta over dt. Can't I cancel a 15 from both sides here? And then divide both sides by 9. We finally got it. That's tough. This is tough for me. Does that help going through it again? Okay. Alright, I'm going to let you guys work for a while. So what I want to do is give you guys today and tomorrow to work on this packet and or your con. This is like your related rates practice time. And then we'll move on Monday. So you got the answers. If I can help, let me know. guess we're not done with this yet, but I'm gonna put a check mark. 'Cause I can know it. And these two are shorter topics, not that bad. And we'll have a couple days to